Hi guys, welcome back to another update for VKEngine. As you can see, I've added a ton of stuff since last time, so let's just jump over to the engine and go through all of the new features. First of all, I've added a skybox, so we now have a more interesting background than just a solid color. I've also added cube map reflections from the skybox with a Fresnel term. So if I demonstrate on this guitar, you can see if we look straight on, we just see the texture, but if we look at a grazing angle, we can see the reflections from the environments, just as you would observe in real life. Second of all, I've added transparency support both for alpha tested and alpha blended objects. This grass, for instance, is an alpha tested quad that's being drawn 1600 times using instance rendering and is distributed over the ground plane. And the windows are being drawn using alpha blending, and as you can see, the transparency is resolving correctly even when I layered the windows on top of each other. I've also implemented a mesh-based instancing system with bindless textures, so when drawing opaque objects, I loop over every mesh and draw all the instances simultaneously. And the textures can also be overloaded. So with these 4 houses, for instance, they are being drawn with one draw call, but you can see here I've referenced a different texture for that instance. And I've also fixed a synchronization issue I had by introducing a dynamic storage buffer for the per frame lighting data. So here's the roadmap for the features I'm going to work on next. I'll implement normal maps, frustum culling, skeletal animations, cascaded shadow maps, and deferred rendering. I've decided to postpone moving to physically based materials for now, since I've implemented it before and it would really slow down the iteration speed for assets. And let's quickly talk about that synchronization issue. So when we're using double or triple buffering, how should we handle buffers that need to be updated every frame? Well, the classic solution is to create one buffer per frame in flight, and this works fine, but it is inefficient and it's a hassle to manage on the descriptor side. I think a better solution is to use dynamic buffers, where you create one double or triple sized buffer and offset into it based on the current frame index. The only catch is we need to account for GPU alignment here, which can be accomplished by simply querying the physical device when creating the buffer. So here's the code for my dynamic SSBO lighting buffer creation. As you can see, I check an aligned size that satisfies the GPU and then multiply by how many frames I have in flight. Then the rest of the creation is pretty standard. And when updating the buffer, we simply compute the per frame offset and memcopy into the correct region. And then when binding the descriptor set, we pass that offset as the dynamic offset field. And this can also take an array, so we could have many per frame buffer updates synchronized easily like this. As always, thank you for watching. You can find the source code located below, as well as some resources for learning computer graphics on my personal website here. Feel free to subscribe if you want to follow along with the development of this project, since I will be posting more videos in the future. Thanks.